Alright, so how would you integrate 1 over x to the power 4 plus 1? Now for this type of question, you need to add something to it and then take something away. So x to the power 4 plus 2x squared plus 1. But remember, if you're adding something, you've got to take it away to make it the same. So you've got to take away. So can you see that the denominator is exactly the same? You've got to add something and then you've got to take away. Now you've got something that looks like the difference of two squares, because you can factorize x to the power 4 plus 2x squared plus 1 into x squared plus 1 all squared minus 2x squared. Now you're going to have a square root 2, but it's doable. So here you've got difference of two squares. So v squared minus u squared will be v minus u times v plus u. So here you're going to have brackets x squared minus root 2x plus 1 and then multiplied by x squared plus root 2x plus 1. And now you've just got to use partial fractions. So you've got to use ax plus b, all divided by the left hand side, and then plus cx plus d, all divided by the right bracket. So you've got ax plus b divided by x squared minus root 2x plus 1, and then you add cx plus d all divided by x squared plus root 2x plus 1. Now here you've got to compare coefficients. So I'm just going to cross multiply here, and then you compare coefficients of x cubed, x squared, x, and constant. Alright, so what happens when you multiply ax with x squared? You get ax cubed, so that's a. You don't have any more x cubed. Now remember, when you multiply it, when you add up the two fractions, the top number is going to be 1. So there's no x cubed, no x squared, no x, but there's only a constant which is 1. So compare coefficients of x cubed, you get a plus c is equal to 0 because there's no x cubed. For x squared, you compare the ax and the root 2x. When you multiply them together, you get a root 2. So root 2a plus b, because b times x squared is bx squared, and then you have the cx and the minus root 2x, so minus root 2c, and then add d is equal to 0. There's no x squared coefficient. Ax times 1 is ax, so you got just a plus b times root 2, which is root 2b, and then minus, you got the cx and the 1, which is plus c, and then d times minus root 2. So minus root 2d is equal to 0. And then the coefficient, you're only left with 1, which is 1. One constant, which is plus 1. So b plus d equals 1. Right, so look at the coefficient for x. You know that from the top equation, a plus c equals to 0. You can substitute the a plus c equals to 0, so that's gone. So now you're just left with root 2b minus root 2d is equal to 0. And and if two numbers take away is equal to 0, that means they are the same. So b is equal to d. You can take the root 2 out, so b is equal to d. And you know that b plus d is equal to 1. If they are the same, that means you divide by 2, therefore b is a half, d is a half. Now we can use the second equation. I'm just going to rub this off. So you know that a plus c is equal to 0, and you know that b is equal to d, you know that b and d is equal to a half. So we're just going to substitute the b and d into equation 2, the x squared. Because you know that b is a half, d is a half, you add them together, you get 1. Multiply the a plus b equals 0 equation by root 2. So you get root 2a plus root 2c is equal to 0. Okay, for this one here, I'll just move the plus 1 to the right hand side. So root 2a plus root 2c is equal to 0. So here I multiplied root 2 from the a plus c equation equals 0, and then I've just took the two equations away. Sorry, I added them, and then a. So 2a is equal to minus 1. So a is equal to minus 1 over 2 root 2. You know that c is the negative of a, so c is equal to 1 over 2 root 2. A is equal to minus 1 over 2 root 2. Alright, so we can rewrite the fraction. 1 over x to the power 4 plus 1 is equal to, now, because you know that a is minus 1 over 2 root 2, just put that into the equation on the right hand side. Now we don't like roots at the bottom of the fraction, so let's rationalize it. So multiply top and bottom by root 2, you end up with minus root 2 over 4. So minus root 2 over 4. And multiply that by x plus, and you know that b is a half, divided by x squared minus root 2x plus 1. And do the same thing for the other one. So c is equal to root 2 over 4. So root 2 over 4x plus a half divided by x squared plus root 2x plus 1. So we've rewritten that simple thing into a more complex thing. But the thing is, the more complex thing you can actually integrate. So let's just rub all this off. Alright, so the integral of x to the power 4 plus 1 is equal to all of that. So it's just basically rewritten that. Now, I just don't want to have too many fractions at the top. So what if you multiply top and bottom by 4? So you're multiplying it by 4 over 4, which is multiplying by 1, so you're just keeping everything the same. So you're left with minus root 2x plus 2, minus root 2x plus 2, and the 4 goes at the bottom, and then all of that and similar to the right hand side. Now what happens when you differentiate ln of a function? When you differentiate ln of a function, you differentiate the function that's at the top of the fraction, and the bottom of the fraction is the actual function. So let's have a look at the bottom function. If you just focus on the x squared minus root 2x plus 1, what happens when you differentiate that? You get 2x minus root 2. That looks very similar to the one at the top. You just, there's a factor, just the factor of root 2. So the 2x is divided by root 2, and the root 2 is times by root 2 to get the 2 at the top. So we've got to make it look like that. How do we make it look like that? So do we divide by root 2? But in order to divide by root 2, you've got to also times by root 2 to keep it the same. So so we're going to put the 1 over root 2 outside, but we've got the times root 2, because basically you're multiplying it by 1. So we're going to have 1 over root 2 outside, times everything by root 2 at the top, and you're left with minus 2x plus 2 root 2. It's the same thing for that part of the integral. So everything's remaining the same. You're dividing it by root 2, but you're multiplying it by root 2 at the top. And we can take the 4 outside. So now you're left with 1 over 4 root 2 as the constant outside, multiplying everything inside the integral. Right, so we're going to split up the fraction. So we're going to make the top part, we're going to make the numerator look like the differentiated part of x squared minus root 2x plus 1, because when you differentiate x squared minus root 2x plus 1, you get 2x minus root 2. However, there's a minus in front, so you're gonna have a minus ln of the denominator. So I've just rewritten the fraction. So we're going to split the minus 2x plus root 2 as a separate part. So now can you see that we can integrate the minus 2x plus root 2 divided by x squared minus root 2x plus 1. We can integrate that. But then you're still left with the other fraction. If that comes next. So yeah, so we can integrate that. So that would be the ln of x squared minus 2x plus 1, because to differentiate that, you would get that part of that fraction. Because when you differentiate x squared minus root 2x plus 1, you get 2x minus root 2, but you just put a minus in front. Now what about that part of the fraction? Now that part you've got to use inverse tan. It looks very similar to inverse tan, because what happens when you differentiate arctan x? You get 1 over x squared plus 1. Alright, so we've got to complete the square, and you've got to let x plus a constant equals another variable. So how would you complete the square? So x squared minus root 2x plus, remember you've got to half the coefficient of the middle, and then you square it, and then you add the remaining part. Now how would you make it?
Okay, so here there should be a
like
minus. It should be x minus root 2 over 2.
So look, if you integrate 1 over x squared plus 1 dx with respect to x, you get arctan x or inverse tan x. But you've got a half there, so how do you make the half into a 1? You've got to take the half out. Now if you take the half out, you've got to multiply by 2. But there's a square there, so you've got to multiply by root 2 squared. And then I'm going to put the root 2 inside that bracket. So you have half brackets root 2x plus, now what's root 2 times root 2 over 2? You're just left with 1. So inside that bracket now, we just condense the two brackets into one, root 2x plus 1 all squared, and then plus 1. Now the half should, because all of that is at the bottom of the fraction, if you divide by half, the 2 goes at the top. So I've basically rewritten the whole thing. So now at the bottom you're just left with root 2x plus 1 all squared plus 1. Okay, so what happens when you integrate this? So you've got to let root 2x plus 1 equals another variable. Let me just take the 2 root 2 out, it's just a constant. Okay, so like I said, we're going to let root 2x plus 1 equals, let's just say t, and differentiate the top, you get root 2 dx equals dt. So can you see that you've got 2 root 2 dx? All you have to do is just multiply by 2. So now you're just left with 2 dt, because 2 dt would make 2 root 2 dx. So you're just integrating 2 dt divided by t squared plus 1. So you're just left with 2 inverse tan of x, or 2 arctan x. And you know that t is root 2 x plus 1. Substitute that back in. And then now you have plus 2 arctan brackets root 2x plus 1, close brackets. Now that part is similar to what we've just done. So instead of the minus, you're just left with the plus. So it's almost exactly the same. So it's plus ln brackets x squared plus root 2x plus 1, and then plus 2 arctan brackets root 2. Oh no, wait, here I forgot the minus. There should be a minus there somewhere. So there should be a minus there. It doesn't really change the whole thing, it's just a minus. Yeah, so it doesn't change. And then here you just plus. So plus 2 arctan brackets root 2x plus 1 close brackets. So let's rewrite the whole thing. So remember the constant outside, 1 over 4 root 2, and then open brackets minus ln brackets x squared minus root 2x plus 1, close brackets, plus 2 inverse tan or arctan brackets root 2x minus 1, and then add ln x squared plus root 2x plus 1, and then there's no space, I'm going to add 2 arctan close brackets root 2x plus 1. Right, let's just make it more clear. I'm just going to put box around it. Oops, just going to put box around it. That's long.